How humanity harnessed nature's invisible force. Imagine waking up tomorrow and discovering that electricity has disappeared. No lights, no internet, no smartphones, no refrigerators, hospitals stop working, airplanes can't take off, traffic lights go dark. Within hours, modern civilization begins to collapse. Electricity powers almost every moment of our lives, yet most people have never asked a simple question: where did it come from? Surprisingly, electricity wasn't invented, it was discovered. For thousands of years, it existed all around us, in lightning storms, inside strange sea creatures, and even within our own bodies. Humanity simply didn't know how to control it. This is the story of one of the greatest discoveries in history, a journey that began with a piece of amber and ultimately changed the future of civilization forever. More than 2,600 years ago, there were no laboratories or power plants. Science barely existed. Most natural phenomena were explained through myths and religion. Lightning was believed to be the weapon of the gods. The Greeks blamed Zeus. The Norse believed thunder came from Thor's hammer. No one imagined that these terrifying flashes in the sky followed the same natural laws that power your phone charger today. Around 600 BC, a Greek philosopher named Thales of Miletus noticed something strange. He rubbed a piece of amber with animal fur. Suddenly, the amber began attracting dust, feathers, and tiny pieces of straw. Today we call this static electricity. For Thales, it was simply an unexplained curiosity, but that tiny observation would eventually give electricity its name. The ancient Greek word for amber was electron. More than 2,000 years later, that word became electricity. Unfortunately, after Thales, almost nothing happened. For centuries, humanity admired electricity, but never understood it. Everything changed during the scientific revolution. In 1600, an English physician named William Gilbert published a remarkable book called De Magnet. Gilbert carefully studied magnets and mysterious electrical effects. His experiments proved that electricity and magnetism were two completely different phenomena, something no one had realized before. He also introduced the Latin word electricus, meaning like amber. For the first time, electricity became a legitimate scientific subject instead of a magical mystery. Scientists across Europe became fascinated. They rubbed glass, they rubbed silk, they rubbed sulfur. They built strange machines capable of producing bright electrical sparks. Public demonstrations became incredibly popular. People paid money just to watch blue sparks jump through the air. Some entertainers even shocked entire groups of volunteers holding hands, proving electricity could travel through the human body. It looked like magic. But nobody knew what electricity actually was. Then, one man decided to answer a question everyone was afraid to ask. Was lightning electricity? Benjamin Franklin is remembered today as one of America's founding fathers, but he was also one of the greatest experimental thinkers of the 18th century. In 1752, Franklin performed one of history's most famous scientific experiments. During a thunderstorm, he flew a kite fitted with a metal key. As rain soaked the string, electrical charge from the storm clouds traveled downward. Tiny sparks leaped from the key. Franklin had demonstrated that lightning carried electrical energy. Contrary to the popular myth, lightning never struck the kite directly. If it had, Franklin would have died instantly. Several scientists who later attempted similar experiments weren't so fortunate. They were killed by lightning. Franklin survived because he understood the danger, and because he was lucky. His discovery transformed the world. If lightning was electrical, perhaps it could be controlled. Soon afterward, Franklin invented the lightning rod. Instead of allowing lightning to destroy buildings, the metal rod safely guided enormous electrical charges into the ground. Hundreds of years later, skyscrapers, airports, churches, and homes still use the same basic idea. It was one of humanity's first practical uses of electricity. But there was still one enormous problem. Scientists could observe electricity. They could even collect tiny amounts of it. yet they couldn't produce it whenever they wanted. Electricity appeared for only a brief moment and then vanished. Without a continuous source of electricity, it would never become useful. The solution arrived from a place no one expected: a laboratory table, a dead frog. In the late 1700s, Italian physician Luigi Galvani was studying animal muscles. While dissecting a frog, he accidentally touched its leg with two different metal instruments. To his astonishment, the frog's legs suddenly kicked. The animal was dead, yet its muscles moved as though it were alive. Galvani believed he had discovered a mysterious force inside living creatures. He called it animal electricity. The scientific world was fascinated. Could every living thing contain hidden electrical energy? One scientist wasn't convinced. His name was Alessandro Volta. Volta suspected the frog had nothing to do with the experiment. Instead, he believed electricity was created when two different metals touched each other in the presence of moisture. If he was right, then electricity didn't belong only to living creatures. Anyone could generate it. There was only one way to prove his theory. He removed the frog completely. And what happened next changed history forever. In 1800, Alessandro Volta stacked discs of copper and zinc on top of one another, separating each layer with pieces of cloth soaked in salt water. It looked almost too simple to matter, but when wires were connected to the top and bottom of the stack, something extraordinary happened. A steady flow of electricity appeared. For the first time in human history, electricity wasn't just a spark, it could flow continuously. Volta had invented the world's first battery. His invention, known as the voltaic pile, completely changed science. Researchers no longer had to wait for thunderstorms or rely on static electricity. They could create electrical current whenever they wanted. In honor of his discovery, the unit used to measure electrical potential is still called the volt. The battery unlocked a new era of experimentation, and only 20 years later, another accidental discovery changed everything again. In 1820, Danish physicist Hans Christian Ørsted was giving a lecture when he noticed something strange. A compass lying near an electrical wire suddenly moved the moment current passed through the wire. That wasn't supposed to happen. Compasses responded to magnets, not electricity. Yet electricity had somehow created a magnetic field. For the first time, scientists realized that electricity and magnetism were connected. It was one of the biggest surprises in the history of physics, but it also raised an even bigger question. If electricity could create magnetism, could magnetism create electricity? An English scientist named Michael Faraday decided to find out. Faraday's story was extraordinary. He wasn't born into wealth or educated at a famous university. As a young man, he worked in a bookbinding shop. While repairing scientific books, he read every page he could. He taught himself chemistry, physics, and mathematics. Eventually, his curiosity earned him a position in one of Britain's leading laboratories. In 1831, Faraday performed an experiment that became one of the most important in human history. He wrapped wire into a coil and moved a magnet through its center. The result lasted only a fraction of a second, but that fraction of a second changed civilization forever. Moving the magnet generated electricity. Faraday had discovered electromagnetic induction. That principle still powers nearly every electrical grid on Earth. Whether electricity comes from a hydroelectric dam, a coal plant, a nuclear reactor, a wind turbine, or a natural gas station, the process is remarkably similar. Something spins a turbine, the turbine spins a generator. Inside that generator, magnets move past coils of wire. Electricity is produced. The energy source may change, the physics does not. Every time you charge your phone or switch on a light, you're using the same principle Faraday discovered nearly 200 years ago. A few decades later, Scottish physicist James Clerk Maxwell brought all these discoveries together. Until then, electricity and magnetism were still treated as separate subjects. Maxwell proved they were actually two parts of the same force. His equations predicted something even more astonishing. Invisible waves could travel through empty space at the speed of light. Years later, those waves became the foundation of radio, television, radar, Wi-Fi, Bluetooth, satellite communications, and cellular networks. Even visible light itself turned out to be an electromagnetic wave. Maxwell had shown that electricity wasn't just useful, it was woven into the very fabric of the universe. By the late 19th century, scientists finally understood electricity. Now they faced a new challenge. How do you deliver it to millions of people? The answer sparked one of the greatest technological rivalries ever recorded. Thomas Edison believed the future belonged to direct current, or DC. His electrical systems worked well, but only across short distances. Power stations had to be built every few blocks because too much energy was lost during transmission. Then, Nikola Tesla proposed a completely different solution. Instead of sending electricity in only one direction, Tesla used alternating current, or AC. Alternating current could be transformed into high voltages for efficient long-distance transmission and then safely reduced before entering homes and businesses. One power plant could now serve an entire city. It was a revolutionary idea. Edison fought back. He launched public campaigns claiming alternating current was too dangerous. He organized demonstrations designed to frighten the public and convince them that Tesla's system would never be safe. But engineering, not advertising, decided the outcome. Alternating current was simply more efficient. When the Niagara Falls hydroelectric power station began transmitting electricity using Tesla's AC system, the debate was effectively over. Within a few years, alternating current became the global standard. More than a century later, most electrical grids still rely on the same basic approach. Electricity transforms civilization faster than almost any other invention in history. Cities no longer disappeared into darkness after sunset. Factories became dramatically more productive. Electric motors replaced steam engines in countless industries. Homes filled with lights, refrigerators, washing machines, radios, and televisions. Computers followed. Then the internet. Then smartphones. Today, almost every technology we depend on exists because of electricity. Hospitals, air travel, GPS, cloud computing, artificial intelligence, electric vehicles, satellites orbiting thousands of miles above Earth. Every one of them depends on a force that ancient people once believed belonged only to the gods. And yet, the story isn't over. Scientists are building more efficient batteries, smarter electrical grids, and cleaner power plants. Renewable energy continues to grow. Engineers are working to make nuclear fusion, a process that powers the sun, a practical source of electricity here on Earth. If they succeed, it could become the next great chapter in humanity's relationship with energy. It's incredible to think that everything began with a simple observation, a piece of amber rubbed with fur, a tiny spark, a curious philosopher asking why. Over the next 26 centuries, that single question led to batteries, generators, power plants, global communication, space exploration, and the digital world we now take for granted. Electricity didn't appear because one genius invented it overnight. It was the result of thousands of experiments, countless failures, and generations of scientists building on one another's discoveries. From Thales to Franklin, Volta, Faraday, Maxwell, Edison, and Tesla. Each added another piece to one of the greatest puzzles in human history. The next time you flip a light switch or plug in your phone, remember this. You're using a force that has always existed. Humanity simply learned how to understand it. And in doing so, we changed the world forever. Thanks for watching, and we'll see you in the next video.